Hello everyone! The topic for this video is hydrocarbons and alkanes, where we're going to introduce organic chemistry. So hydrocarbons are nothing more than organic compounds that contain only carbon and hydrogen. And because those carbons are surrounded by only hydrogens, we're going to consider hydrocarbons to be nonpolar. And when we say the word alkanes, alkanes are simply hydrocarbons that only have carbon-carbon single bonds. So that means no double or triple bonds. Alkanes only have carbon-carbon single bonds. And if you see the word heteroatoms, that simply means any atom other than carbon and hydrogen. Now we can represent these organic compounds in several different ways. And we have looked at molecular structures and Lewis structures before. A molecular structure might be something like CH4, and Lewis structures are shown down in this bottom left-hand corner. Okay, so we've seen molecular and Lewis structures. The two new ones that we're going to look at today are condensed structures and skeletal structures. And skeletal has several different names. It could be skeletal, line angle, or line. Now, when we look at some examples of each of the different types of structures, remember that a line structure is your skeletal structure. Okay, and the expanded structure is simply your Lewis structure. So Lewis structures show every atom, every bond, and every non-bonded electron, or every set of lone pairs. The condensed structure is where we remove the bonds between the carbons and hydrogens. And so we package those hydrogens together with each carbon, depending on the carbon it's attached to. So if you notice, this carbon in blue has 3 hydrogens, and therefore we want to label the carbon on the end as CH3. And then the 2 carbons in the middle, the green and the red, each have 2 hydrogens, so notice how those are CH2. And then the black carbon on the end also has 3 hydrogens, so we label that as CH3. Now when we jump down to the skeletal structure, we're going to remove all of the atoms and only look at the bonds between carbons or possibly carbons to heteroatoms. But we will not see any bonds between the carbons and hydrogens, just like in the condensed structure. Now the best way to do this is to number the carbons in your condensed structure. So we want to label them from left to right, and therefore you have carbon 1, 2, 3, and 4. And this does not represent the number of carbons. This is just labeling those carbons with a number so that we can describe where they're at in the skeletal structure. So in a skeletal structure, at the end of every line is a carbon, and every corner represents a carbon. Okay, so that skeletal structure shows 4 carbons, 1, 2, 3, and 4. And in our second example, notice how that middle green carbon now has a carbon attached at the top. When we represent that in condensed structures, it could be represented at the top or at the bottom. So both of these condensed structures are the same. And again, if I want to number the carbons, it's best to go from left to right first, that being carbon number 1, carbon number 2, carbon number 3, and then label the outer carbons, the ones on top or bottom. And so carbon number 4 we're going to place up top. And then in your skeletal structure, again, every end of a line represents a carbon, and every corner represents a carbon. So all 4 are shown there as well. 1, 2, 3, and 4 up top. Okay, so let's practice several examples of how to convert between these types of structures. The first one asks us to draw the Lewis structure given the formulas shown below. Now, it will help to remember how many lone pairs that you have for each type of atom. Remember that carbon had 0 lone pairs, Nitrogen had 1 lone pair. Oxygen has 2 lone pairs typically. And fluorine, chlorine, and bromine all have 3 lone pairs. Okay, so in the Lewis structures, we have to show those lone pairs. And in part A, notice how we have an oxygen, and an oxygen has 2 lone pairs. So we're going to have to add the lone pairs around that oxygen. And then the other step is to show the bonds between every carbon and hydrogen, or oxygen and hydrogen in this case. And if I label the carbons, that's number 1, 2, 3, and 4. So we need to have 4 carbons across, 1, 2, 3, and 4. And then the first carbon has 3 hydrogens. So we're going to attach 3 hydrogens to that first carbon. The second carbon only has 1 hydrogen. So we'll place that underneath. And the second carbon is also attached to an oxygen, which has a hydrogen coming off of it, as well as 2 lone pairs. The third carbon has 2 hydrogens, so we'll place 1 on top and 1 on bottom. And then the last carbon has 3, so we'll place 3 around that last carbon. Okay, now the second one's a little more difficult. We're looking at those skeletal structures, and so sometimes it may help to draw out the condensed structure first and then the Lewis structure. So we want to start off by deciding where our carbons are located. And remember that a carbon is going to be located at the end of every line, unless you see an atom already at the end of the line. So in this case, those chlorines are at the end of those lines on the left and right side, and so we're not going to show a carbon coming off of that chlorine. But you do have a corner here and here. So you should have a total of 4 carbons. So if we show those carbons, that's about what it should look like, with 2 chlorines, 1 on the top right and 1 on the bottom left. And now each carbon has to have 4 bonds. So remember from the Lewis structures that carbon has 4 bonds. Which means that some of those hydrogens are hidden, and we have to add hydrogens until every carbon has a total of 4 bonds. The first carbon we'll label as the top left. The first carbon here has only 1 bond currently to that second carbon. Okay, so we need to add 3 more bonds to that carbon. Which means that we need to add 3 hydrogens. Okay, the second carbon, so the carbon in the top middle here, it has a total of 4 bonds already. Okay, so if we notice, we have the bond between carbon number 1 and carbon number 2, that's 1 bond. To chlorine is 2, and then it has a double bond to the carbon below it. So that gives you 3 and 4. So that carbon has a total of 4 bonds already. And if we notice, carbon number 3 also has 4 bonds because it has the 2 at the top as well as the 2 on either side of it. So both carbon number 2 and 3 already have 4 bonds. And then carbon number 4, it's like carbon number 1. It only has a single bond right there. So we need to add 3 more to give it a total of 4. Okay, and then the last step is to add any lone pairs, and the only thing that needs lone pairs is the chlorine, where chlorine has 3 lone pairs. Okay, so each chlorine needs 3 lone pairs. And that is our final Lewis structure. Now in the next set of structures, we're going to be asked for the molecular formula given the structure below. And the molecular formula, remember, that just lists the number of carbons, the number of hydrogens, and any heteroatoms that you might have on the end in alphabetical order. So what we need to do is count up the number of carbons and count up the number of hydrogens. Okay, so if we count up the number of carbons, we've got 1, 2, 3, 4, 5, 6, 7, and 8. So that gives us C8, and then we have to determine the number of hydrogens. And counting those up, you have 3 plus 2 plus 1 plus another 3 plus 1 plus 1 and plus 3. And that should give you a total of 14. So our molecular formula is C8H14. The next set of structures are skeletal, and so again, it will help if we first write out what is the condensed structure for each of these. And the first step is to determine where the carbons are located. And remember, those carbons are going to be at the end of every line, except where bromine is already at. And we've got carbons at every corner. Okay, and if we label these across, that's 1, 2, 3, 4, 5, and then the 6th one below. Okay, so if we want to start off by doing a condensed formula, or you can do expanded if expanded is easier, we'll have carbon number 1, carbon number 2, carbon number 3, number 4, and number 5. And off of carbon number 3 is carbon number 6. And then on carbon number 4, there's a bromine. Okay, and next we're going to have to add in the hydrogens based off of the number of bonds that each carbon has, remembering that carbon needs 4 bonds. So carbon number 1 only has 1 bond, meaning that it will need 3 hydrogens. Carbon number 2 has 2 bonds, so it needs 2 hydrogens. Carbon number 3 already has 3 bonds, 1, 2, and 3, so it only needs 1 more hydrogen. Carbon number 6 only has 1 bond, so it needs 3 hydrogens. Carbon number 4 already has 3 bonds, 1, 2, and 3, so it only needs 1 hydrogen to give 4. And then carbon number 5 needs 3 on the end. Notice how any carbons on the end that are singly bonded only need 3 hydrogens. So we're going to list out the number of carbons, which we already counted to be 6. And then we've got to count up those hydrogens. So we've got 3 plus 2 plus 1 plus another 1 plus 3 and plus 3 on the bottom. And that should give us a total of 13. And then last, we want to add that bromine on the end. Okay, giving us a final molecular formula of C6H13Br. Okay, in the next video, we will pick up with more examples.